Hello CIS 1400 and welcome back to another module. This particular module is going to cover chapters 4 and chapter 5 where we talk about decision structures, Boolean logic, and looping statements. So if you haven't yet read chapters 4 and 5, please take some time to go do that before you start watching this video. This week's module is going to be broken up into a few parts. We're going to go through kind of the basics in this little presentation here pretty quickly, to be honest with you. And then we will have a few other videos on a couple of examples that utilize both selection and looping structures. So stay tuned for those as well, and make sure you sign in and watch those videos as they become available. So let's get into it. We'll talk about kind of the basics behind what we're going to get into, and then we'll show you the practice of it a little bit later in another video. So first and foremost, decision structures. So far our programs have been pretty bland, to be perfectly honest with you. They've been doing a selection, or not selection, a sequence of instructions. So it's do one thing, do the next, do the next, do the next, where most programs don't do that. They generally tend to answer questions for us, and those questions are always of the true, false, or yes, no type. Anything that can be broken down into a binary question, any question that has two possible answers, is what we would like to ask of the computer to answer for us. So a couple questions that you could ask that have a binary state are something like, is it cold outside? The answer could be true or false, yes or no. And if the answer is yes, we might want to wear a coat. If the answer is false or no, we wouldn't want to wear a coat or do anything special at all. Our selection structures could also have many different instructions within them. So if we come in and ask a binary question like, is it cold outside? If the answer happens to be yes or true, we then come into this sequence structure like we've been doing all along, where we wear a coat, wear a hat, wear gloves. Now, yes, I understand these aren't programming statements or anything like that, but the idea is just to give you a for instance of what a binary question is. Any question that has two possible answers, yes, no, true, false, or whatever it may be, and then based upon the answer, you can do certain things with it. Now, these particular statements that we see here are examples of single selection, one-way selection structures, where there's, if the answer comes out yes or true, we do something. Otherwise, if it's false, we continue on with the program like it never happened. Okay? These statements in here are what we call conditionally executed, because the condition must be true in order to execute them. Okay? Now, how it really works is you have to include some sort of operator or Boolean operator that will allow you to evaluate the expression as being true or false within the condition. Okay, so over here, when we're dealing with, say, numerical expressions, we could say that things are greater than, less than, greater than or equal to, less than or equal to, or not equal to. Okay. So with these, we can easily make a true-false statement. Something like, if sales is greater than 50,000, then we might set the bonus to 500. Sales is a variable that's somewhere set in the problem previously to coming into the selection structure. And if it happens to be a number greater than 50,000, we will do these statements inside the condition body. If it happens to not be greater than 50,000, then we would just skip it and move on with the rest of the program. They're really kind of basic and simple to work with. They're yes-no questions, true, false, but these relational operators that we have here are very, very useful in finding ways to answer said questions. We could say if sales is greater than something, or if sales is less than something, greater than or equal to, less than or equal to, if it's strictly equal to, or if it's not equal to something. And we can ask all sorts of other questions. We could say if your GPA for high school is greater than a 3.5, you were selected to the honor roll. Or if your ACT score is greater than a 27, then maybe you are eligible for a scholarship. And if it's greater than 24, you're eligible for admittance into a certain college or university. So there's all sorts of other types of statements you can make that would allow us to make a decision, yes or no, and to do something if the answer happened to be yes. Right? So what we just showed are what the book refers to as a single alternative statement, which you'll see is the if-then statement most of the time, because your statements always start with a question that begins with the word if. Okay? So when you're writing it, you have this condition that when it's true, an alternate path is executed. So if it's true, we do this sort of stuff. If it happens to be false, then we continue on with the program like it never existed. The pseudocode conventions, you want to make sure that your if and end if clauses are aligned, so you'll keep those kind of left aligned. It makes it a little bit easier to read, and that the indentation of the conditionally executed statements is all aligned too, but at least indented one level, and that's pretty important not just for pseudocode, but especially for Python code. If your spacing isn't 100% right, your code's not going to execute because the spacing is what makes blocks of code, okay? When it comes time to write it in a flowchart form, we will use the diamond shape to signify that a question is being asked. So we don't actually use the words if or while when we get into looping structures, but we just simply put it in a diamond and we write the condition, sales greater than 5,000, 50,000. There we can interpret whether or not it's an if statement or something else based upon how the flow lines all look. So all the conditionally executed statements are always on one side of the diamond or the other, and the flow lines always come back to meet below the diamond in some way, shape, or form just to keep things nicely aligned. And you'll see that in later examples they can get rather large because we can ask multiple questions based upon the answers of other questions. So you want to try to keep things as neatly organized as you can. Okay? Sometimes our statements aren't as simple as if it's true, do something, and if it's false, do nothing at all. Sometimes we want to do something based upon the answer being yes or no, true or false. And so we call these dual alternative statements, or the if-else structure. This is a statement where one group of statements is executed when the expression is true, and a completely separate group of statements is executed when the statement is false. In never will both statements ever execute, but one will execute or the other, never both at the same time. So when you're doing things in pseudocode, again, you want to keep things nicely aligned, your if and your condition, and then your block of code indented, and then the word else, meaning that if this was not true, we do this instead, display nice weather we're having, and then of course the end if clause to kind of show that the selection structure is over. When it comes to flowcharts, we will again keep things to the right or left of the diamond. Generally to the right we'll write the true statement, and to the left we'll write the false. Keep things simple and organized, but again our flow lines when done with the programming statements will always come back and meet underneath the diamond in which they were created. So to keep things nice and neat and organized so I can really see what the structure is, and I don't need this end if kind of here in a flowchart because I know when the flow lines come back to meet towards the middle, then that happens to be the end of the selection structure altogether. Okay. As I mentioned before, the questions can be more complex than just yes, no, true, false. They can be different questions embedded within questions, meaning that if the answer is true, maybe we have another question we would like to ask. So these are what we call nested structures, placing one structure inside of another structure entirely. So what we can do is either stack them, put them one after the other, or in this case nest them, where one answer is, or one question is dependent upon the answer of another question. So for this, what I'm trying to do is determine whether or not somebody is qualified for a particular position or something of that nature, or qualified for a loan, I'm sorry. So here I have a flowchart that says, okay, if my salary is greater than $30,000, okay, if that happens to be true, then I can look and see how many years I might have on a job. And if the answer of that is greater than or equal to 2, then I qualify for a particular loan. They know I'm a person who has a steady job as well as a steady income. They have a good feeling that I can repay the loan, so outside of that, I should be qualified for the loan. However, I could also answer true to the greater than $30,000 but not have 2 years of experience. So they might display some message here saying you must be on your current you must have been on your current job for at least 2 years to qualify. So that would then bring it back together and come to the end, so I didn't qualify for it. Had I initially not had the income, then it would have just terminated the idea of me getting a loan right away. They wouldn't have even asked this job question because it didn't make a difference. If I didn't make the 30 grand a year, then they weren't even interested in how long I've had the job. I could have had it for 10 plus years. If I didn't make the minimum salary that they required me for earning the loan, then they weren't going to give it to me anyway, so they just cut me loose and said you must earn at least $30,000 per year to qualify. So this is what we call a nested structure. So we have one question nested within the answer of another. Now this nested structure could fall on the true or the false side. It really doesn't matter, just as long as we understand that it's one structure within the other. All right. So when we start nesting these structures, like I said, we can have them on the false side. When we do that, we call them mutually exclusive decisions. So when one score doesn't really affect the other choice. So in the previous example, what we had is that I had this question was asked only if this one was true, which means this question was dependent upon the answer to this one. In this particular slide, when we're calculating grades in this particular manner, this is what we call a mutually exclusive event. This occurs when we nest decision structures can be simplified when coding, and what we do is we call this an else-if clause or an else-if clause. And so here we have decisions that are made that only one choice can get made no matter what. So if I'm calculating grades and I want to display if somebody got an A, B, C, D, or F for a particular grade, say a final exam or a test, I can look at their score. If the score happened to be less than 60, well, then they got an F on it and it exits. It's a mutually exclusive decision. You cannot have both an F and a D at the same time. It's just not possible. However, if their score was not less than 60, it might be less than 70, which would put it between that 60 and 70 range. Excuse me. And if that was true, then they would have a D. However, if it was false, it could be less than 80, which would put them between that 70 and 80 range. So they could have a C if it was true. However, false, excuse me, would put it at a B. And if it was again false, put it at an A. I could code this exact same thing in reverse order. I can judge whether or not the score was greater than 90, and if it was, display an A, and if that was false, I could judge if it was greater than an 80, in which case it would be a B, and I could work that all the way back to down to a D and an F. So there's no one right way to do these types of structures, but what you do notice about these structures is that the next question is always asked on the false side of things, because this eventually was not true. And since it's a mutually exclusive event, only one of these displays will ever happen. You can never have two, which is really kind of neat and nice. And it does code really well, especially when we start working with Python's else-if clause. Okay? It allows me to just pick one path, and as soon as that becomes true, then we stop looking. So you notice how these flow lines, once you go to the true side, it comes back and it exits the selection structure right below where it started. So we'll do some examples with that, maybe a grade example just like this to make sure we understand how it codes up, and so you can see it in action. Okay. The next thing we want to discuss is that sometimes questions just aren't as easy as one single binary question. Maybe there's two or more binary questions that need to be asked in order to decide which path to pick. Okay. So we have a couple operators here that can help us with that. We have what we call a logical and the logical or. Okay, they're both fairly simple to work with. What you would do is put them between two Boolean structures, maybe something like if temperature is less than 20 and minutes is greater than 12. Then display the temperature is in the danger zone for maybe frostbite or something of that nature. So the logical and is a really nice operator when you need both conditions to be true in order for the overall expression to be true. It wouldn't make sense to display the temperature is in the danger zone if one of these two things just didn't exist. Let's say I was only out there for 2 minutes and it's still below 20. I'm not really in danger of frostbite then, depending on the temperature, obviously. If it was greater than 20, then who cares how long I'm out there? I can be out there as long as I want. And again, I'm not in danger of frostbite. But when I am in danger is when the temperature is less than 20 and I may be outside for greater than 12 minutes. Okay? So that would put me in the danger zone. So your logical and ends up true and only true when both the left and right side of the and operator result in true expressions. So temperature less than 20, true, and minutes greater than 12, true. True and true makes this entire expression to be true, which means I would run the indented code. Anytime you throw a false in next to an and statement, the overall expression is false. So if either one of these came up false or both came up false at the exact same time, then the overall expression would be false and the indented statements would never execute. Okay. Now conversely to that, we have what we call the logical or. Sometimes I want to know if one thing or the other may be true, and if either of them is true, then the overall expression is true. So what you'll notice with the logical OR is that we get the ability to hit true more often. So if I have a true statement or a false, so if temperature is less than 20 or the temperature is greater than 100, then I might display I'm in the danger zone. It's too cold or it's too hot to be outside for any period of time. Oops, sorry about that. Maybe if they're both true, which in this particular example, since these are two pretty mutually exclusive events, would never happen, but it could possibly happen where you're judging two completely separate things, not just temperature and temperature, but maybe temperature in minutes again. And that logical OR could result in both statements being true, which in the AND statement would be true, but it's also true in the OR statement. So for the OR to be true overall, either one or the two or the other expression must be true. So the only way to get a false is if you have two falses. So let's say my temperature was 65 degrees. Well, it's not less than 20 and it's not greater than 100, so I'm not in the danger zone, which means I'm not going to display this particular thing. So ANDs are pretty simple. Put an AND between two Boolean structures, and both must be true in order for the resulting expression to be true. For the logical OR, either or could be true. Both could also be true for the overall expression to be true. The only way to get false with an OR is if both are false, and the only way to get a true with an AND is that both expressions are true. Right? So that kind of wraps it up for selection structures. Again, that's pretty short in terms of explanation. You'll see more usage, and we will talk more as we start getting into the finer details of it when we code it. But now time to move on to some repetition structures. So a repetition structure is very similar to a selection structure. It's based on some sort of condition, okay? And if this condition happens to be true, we're going to execute some statements. The only difference is with the looping structure, when this condition is true, we execute the statements, and then we come back and ask the question again. So in the selection structure, we only asked it one time, but with a looping structure, we could run it multiple times, and we keep running it over and over and over again until this condition becomes false, and we would finally exit. So with that being said, one thing you need to make sure of is that somewhere in these statements you are doing something that would force the condition to become false at some point in time. What that point in time is completely up to you and how the loop is going to work. But if you don't and fail to change the condition to be false in some way, shape, or form at some point in time, you get stuck in what we call an infinite loop, and your program will run forever, theoretically. Okay? Setting it up is pretty simple. While is the keyword here, the condition, and we have some statements, and we might end the while. There are actually two different types of looping structures. We have a condition-controlled and a counter-controlled, and we're going to talk about both as we go through. Okay? So the while loop is what we call a condition-controlled loop. The while loop gets its name from the way it works. While a condition is true, you do some tasks, and the loop has basically two parts. You've got a condition that has to get tested for true or false, and a statement or set of statements that are repeated as long as the condition are true. And as I said previously, you have to modify the value being tested in the condition so that the condition will become false in some way. If you fail to do so, like I said, we're stuck in an infinite looping structure. Now, with that being said, this condition is probably going to be some Boolean condition that's based off of something like these, an operator. Maybe it's something while my number of employees is less than 5. I keep doing something and keep entering employees, whatever it may be. I have to make sure that I initialize some variable that I'm being checked in this condition prior to getting into the loop. And you'll see some examples of that as we get into it. And then in these statements, I'm making some adjustments to that variable that I initialized prior to the loop, so that eventually this becomes false. That's usually the way we would go about it, okay? When we're pseudocoding these, it looks a whole lot like an if statement, but instead of using the word if, we use the word while to signify it's a looping structure, some condition. We indent, again, the statements we would like to execute while the condition is true, and then eventually we'll end up with an end while here that should be left aligned with the while statement, okay? In a flowchart, the diamond is still used, okay? On true and only on true do we loop the statements. We will never loop on false. Okay? False is how we get out of the loop. But the only difference between a while loop and an if statement in flowchart form, since you're not actually writing the question in here, is the flow lines. You'll notice that the flow lines don't just come out and meet back towards the bottom. The true side always loops back to the condition. It should, if we're doing it correctly, always come back to the condition. There are other types of loops in which the condition would actually be at the bottom of the statements, but in a while loop, the looping structure should always come back to the condition. Okay? The other looping structure you may need or see, Python doesn't have this looping structure, but some of you may have noticed it in, say, Java or C. It's something called a DoWhile loop, which is a post-condition loop, whereas a while loop is a precondition loop. In a while loop, you have to check the condition to see if you're going to do the statements first. In a do-while loop, it's actually reversed. You do the statements and then check the condition to see if you should do them again. Notice the flow line actually doesn't come back to the question. The condition being asked actually goes back to the statements. The one advantage to a do-while loop that the while loop doesn't have is that you are forced to execute the loop body at least one time. And that could have its advantages. Let's say you're working with an ATM. And you want to get into a structure in which you're asking the person for their PIN number. Well, you should at least ask the person for their PIN number one time, and if they type it incorrectly, you might want to ask them to type it in again. And if they type it incorrectly, maybe one more time. But either way, you do want to make sure they enter their PIN number one time. So that would be a nice use for something like a do-while loop. Have them go through the loop body and then check to see if a condition is true. Maybe something like while their PIN number is incorrect. Do it again. While their PIN number is incorrect, do it again. Hopefully the real ATMs out there are a little bit more sophisticated than that, which they are, but you kind of get the point from that particular example. It's always do the statements and then check to see if you should do it again instead, and the loop body comes back. Either way, both work. We're not going to spend a ton of time with the do-while loop, at least for pseudocode, flowchart, and actual code for us, because Python doesn't have a do-while loop. Anything you can write with a do-while loop, you can always write with a while loop, and vice versa. So we're going to spend most of our time focusing on the while loop, but it is something to note that some of you may have seen in other languages. Okay? The last kind of looping structure we're going to talk about, since those two were condition controlled, this is what we would call something like fixed repetition or maybe counter controlled. A for loop, okay? There are many different variations of the for loop out there in different languages. Python has its own way of doing it based on sequences, whereas like Java has a way of doing it based on, again, a conditional statement, but they're all basically the same idea. You come up with some sort of counter or a starting value, and then you ask yourself whether or not the counter is less than some max value that you like. Or maybe you're counting down and you want to see if it's greater than some sort of minimum value. Doesn't make a difference, but you have some sort of condition there. You have an initial value and you have some sort of condition. When it's true, you do your statements and then you increment the counter, and generally you increment by 1 because you're trying to keep track of how many times you've executed this loop body. Maybe I know I need this loop body to execute 100 times, so I start my counter at 0 while it's less than 900, add 1 to counter, and it will go through 100 times. So that's basically the setup of a for loop, or what we might call a counter or a fixed repetition loop. So the trick is getting it to run a specific number of times. Very useful when you say you have a list of items to go through and you know exactly how long this list may be. Or if you've got a collection of characters and you know exactly how many characters there are that you want to process in a string. So there's many uses for a for loop. You'll probably find even more uses for a while loop, depending on how you want to structure it. Both have their advantages, and they're great tools for the right type of job, and that's going to be our goal here, is to try to identify which looping structure is best for our problems as we go through. Okay. Now the last thing I want to touch on today with this particular video is something that's a little less kind of pseudocode and flowchart and more general basics, but some of the Python structure and the for loop. Like I said, Python's a little weird in how it does it. The for loop is actually a sequence controlled loop, so you need a sequence to iterate over instead of keeping track of how many times you're actually going through the loop. So we have lots of different sequences that we can work with: lists, strings, stacks, and all sorts of other things. The simplest of which that we're going to start with is a range object or a range function that will produce a sequence of numbers for us. Again, I'm going to show you how to do that in the next set of videos, but the Python range function is a very interesting function. You call it very easily. You just say range of and then some value, and you can insert all sorts of values. Let's say I were to insert a 10, it will produce a series of 10 digits starting at 0 through 9 that I can iterate over and use. Okay? If I needed a definite start and stop, well, I can do that. 5, start at 5, end at 10, but don't include it. So 5, 6, 7, 8, 9. I can start at 0, end at 10, but count by 2s. 0, 2, 4, 6, 8. So when we actually start coding and getting into some of these structures, we'll show you how that's all going to work. We're going to get through some Python examples first, and then we'll do kind of one small kind of project together. We'll build a guessing game where you can see how to flowchart pseudocode and then eventually code said example. But we'll do some very simple Python examples to start off with without any flowchart or pseudocode, so you can at least see the syntax and how all of these things working. So stay tuned for those particular videos. They're coming up next. Hopefully this was short, kind of to the point, and it allowed you to kind of see what the reading was about and get further explanation on what you may have read. Check out the next set of videos where we will start coding some basic selection structures and looping structures, and then the third video where we will actually do, like I said, a guessing game through pseudocode flowchart and eventually into Python code, so you can see actually how it builds up into something a little bit more dramatic. So yeah, click over to those other videos, and if you have any questions, again, leave them in the discussion forum for the particular module so everybody can see what those questions are. And we'll see you in the next video.